Hey guys, so it's Mr. Murray, and we are going to talk about atoms right now. So, the whole deal with atoms is that we are um, kind of composed of matter as living things, as creatures. We're composed of matter, so that's why we study matter in biology. And so, all matter, right, is composed of three major parts, right? So, if we talk about an atom, that atom is going to have three major parts. So we'll just for giggles, we'll do an atom of, let's say, carbon, right? So that atom has three major parts, and inside of that atom, there's two real big places to be concerned about. So the first place is the nucleus. Now, inside of the nucleus, we're going to find two of those parts that we just discussed. One of those parts are the protons. So protons reside or live in the nucleus. Okay, more on them in a little bit. The other thing we're going to find in that nucleus is neutrons. Okay. Outside of our nucleus, now for the purposes of our discussion here, this is not anywhere near to scale, but outside of our nucleus in these things called energy levels, we're going to find what are called electrons. Okay, so that being said, we're going to dig into each of those for just a moment. The electrons that are outside, and they're in energy levels outside of the nucleus, and so they're going really, really fast, and they're insanely light. So electrons effectively have no mass. Okay, they go really, really, really fast. They're outside of the nucleus. So we'll just make this into a little table here. So we'll say mass, no mass. Now that's not totally true. They have some mass, but for our purposes, we don't really care. All right, so we're gonna do now, we're gonna do charge now. The charge on an electron is -1. And the last thing we're gonna add to this column is a location. And so the location for electrons is going to be outside our nucleus. Okay, so the next one for our little table will of course be protons, because why not? So our protons, where'd this go? Here we go. Our protons, we'll keep the color going here. They have a mass of 1 atomic mass unit. Okay, they have a charge of +1, and their location is in the nucleus of our atom. All right, what was our other color? Blue. All right, so here's where we get to neutrons. Our neutrons have a similar mass to protons, a mass 1 atomic mass unit, or AMU. Their charge is 0, so they have no charge, but they are part of that nucleus, just like protons are. All right, so that concludes our little story on what's inside the atom so far, but let's just do a little, just for giggles, we'll do a carbon atom here. Okay, so what we need to be able to do is model things in science, and so to visually explain what's happening, we're going to just make a model of a nucleus, or of a whole atom, my apologies. So our nucleus, let's just go back here. We're going to do carbon, the atom. Carbon has an atomic number of 6, so we'll make this sort of like what you see in your periodic table. It's an atomic number of 6, and it has an atomic mass of like 12.0 something. We'll say 0.1 for the purposes of our discussion. All right. So how do we model this atom that we know and are made up of, called carbon? So the first thing we're going to need to do, by the way, this is a 6. We're going to clean this up a little. All right. First thing we need to do is go to our nucleus. So let's draw our nucleus, which was yellow before. So we'll go with that again. So here's our nucleus. All right, so to model that nucleus, we're going to say, we're going to need some information about what's in it. Now, because this atomic number is here, it tells us a lot about our atom. It tells us that that nucleus has 6 protons in it. And we're not going to draw them because they might not look that pretty if we do. So atomic number is 6, we have 6 protons. That's sort of a big deal. My atomic number is also known as my proton number, but the people that were figuring this out in the beginning didn't really know that yet, and so they just called it the atomic number. All right, so that's happy and good. All right, so in our nucleus we have 6 protons. Now, we're looking at carbon. It has a mass of 12, and so the isotope that we're going to work with here is carbon 12. So that's probably our most common carbon isotope. And all that means is isotope just means the kind of atom that we have. So what are we going to have in our nucleus as well? Well, we're going to have total of, let's take a look here. We take a mass number, 12, and we subtract those 6 things that we already talked about, protons that had mass, and that gives us 6 as a mass left over. So that mass left over is due to our friends, whoa, I don't know what just happened there. That got funky. Oops, okay. Something happened. All right, here we go. That mass left over is due to neutrons, so we have 6 neutrons in our nucleus. All right, so what do we have left? We just have to deal with our electrons, right? So let's scroll up here and see what we had. So our electrons, remember, we had no mass and they were outside of our nucleus. So we're going to come down here, go back to our model. Now our models get a little messy here. I got a lot of math going on, so I'm just going to draw it again. Here's our nucleus. We said we had, real quick color check here. We said we had, in here we had 6 protons. We said, I think it was blue for neutrons. We said we had 6 neutrons. All right, so now what's left? If we're describing an atom, it's important that we know, we'll go to black here. It's important that we know in an atom that there is no net charge. All right, what do I mean by that? Well, I mean that all of our positive things that we have, which are, of course, protons, and all of our negative things that we have, which are, of course, electrons, are going to add up to a total charge of 0. So if I have 6 protons, I'll do a little math over 6 protons, I need to get to 0. Okay, so 6 protons plus something, right? So what's the something? The other something that has charge is electrons. Okay, so that gives me 6 in the plus category, so it's 6 plus. I got to get to 0, so of course I need 6 electrons, which will give me a 6 negative charge, and that gets me that magic 0 that I'm looking for. So around the outside of this atom, we're going to have 6 electrons. Let's see what we can do here. Can we undo that? Let's see if we can undo that. Put my handy dandy eraser on here. Here's that eraser. I'm going to erase. Maybe I do this. Oh, there it goes. Just went away. That's happy. Okay, so let's clean that up just a bit. Those electrons were, of course, green. So we're just going to put our 6 electrons outside of our nucleus right now. Put E negative 6. That didn't come out too fabulous, so we're going to do that again. 6. We're going to go back here, 6 electrons outside of our nucleus. All right, more on that later, how those electrons are organized.